Testing. 1, 2, 3. Testing. 1, 2, 3. Wow. Testing. 1, 2, 3. Holy crap. Thank you for bearing with me. Testing. Oh. You would never guess what happened. I screwed up my ffmpeg command and I could not figure out what was wrong with it. Oh. And I don't even store that stuff in version control because I just never did. So good to know. All right, welcome to the stream. I have no idea what made it so far, but we're on week 113, building my own operating system. Thank you for being here. What's up, Sarab? Nice to see you. Thanks for popping in. Man, I had a rocky start today for sure. Let me just quickly check if that created a like random tiny stream. I don't think so. I think we have a live stream right now, so cool. Let me calm down after frantically debugging my ffmpeg command. Okay, today we're working on scheduling again. This is proving to be a really interesting and deep topic. And I almost feel like the chat widget I want to say it looks like the chat widget is not even active today. Oh wait, the YouTube preview I'm looking at is like way behind, that's why. Okay, jeez, tech issues galore today, okay. Sorry about that. All right, enough of the nonsense. Let's get into things. Hello, warm greetings to the 11 people in the chat. So I'm waiting for a kind of pair program, and it is very productive. Oh, for sure. Let's do some pairing, remote pairing. Subsamud, using Arch BTW. Please make the OS without AI, just terminal based. Nice. Yeah, I think you'll be happy. That's sort of my plan. I don't even have, like, for me, it's just like all serial console for the moment, not even the terminal, like only serial console is the only way you can interact with the OS right now. And it might be that way for some time. Okay, my monitor is like a little bit messed up. Okay. So I feel like I don't know if my text is a bit bigger than usual. I switched terminals to Ghosty and things seem bigger. Let me just quickly review my working tree. I did a bit of like tiny little refactors in the meantime. Let me also get the Miro going. What's the date? 29th. Off the top of my head, what's on the list for today? Kernel thread exit, test it some more, test it with a bunch of different threads. Then the idle task, sort of porting things over from last time. Stacks don't run out of the fizz map. Actually allocating a stack properly. These were a few things from last time. Have you worked on local first apps, peer-to-peer software? No, I have not worked on peer-to-peer software. No. Sheesh, I'm late. What's up, VA80? Nice to see you again. Thanks for popping in. You're building a nice streak for yourself. Dang, I'm so damn excited to see this. Word. Rohit, I got you. I got a resources page with a couple recommendations for people like you looking for this kind of stuff. Okay. All right. Let me just quickly, so I changed a couple of things in the meantime. I did a small change I did is just, I wanted to just pass I wanted to pass a pointer to the handle trap entry point function. Previously we were using the global kernel symbol, and I'm trying to avoid using the global kernel symbol if at all possible. There is a global kernel object. I'm trying to make most of the code not really aware of that. I'm trying to reduce references to that. So what I've done is I've changed the trap assembly to be the one that references it, and then it passes in the pointer to the kernel. It also passes in a pointer to the trap frame. So that is pass kernel to trap entry points. Okay, and then what's going on over here? I was changing a couple things. Last time we were doing the thread exit and stuff. This is also sort of just adding a bunch of whip commits for now. Sorry, I need to refresh myself a little bit. I feel like I'm missing something. Yeah, my commit messages are pretty bad, but let me just remember. So last time we were working on thread exiting, and that was exposing a lot of problems with the scheduler. I was having all these problems. I was storing an index into a vector, and so first of all, a vector is the wrong data structure because any insertions or erases invalidate all indices, or invalidate indices in general. And so I moved to a linked list, and I was using the ETL linked list, and I was having a bunch of problems with that. But I think I've converged on something that is like sort of workable. Maybe I'll just fast forward to the code. What did I just do? Fast forward to the code. So let's just trace through some execution. So a task is running. Let's say it's the test 0. What are we seeing? Here's our kernel. So the kernel is configured to run test 0 for the task. All this does is print hello from task 0, and then it ends. It just falls off the end. What's up, Motive Lab? First encounter in Japan. Oh, got the Japan reporting in for the stream. Nice to see you, Motive. I'm Smit Dangar, VS Code, using VS Code. But I also have my new fancy tools list. Anyway, so test falls off the end. What that is going to do is it's going to trigger the code we have. It was in scheduler. So when we create a task, we place a landing pad function pointer at the top of the stack, and that points to this function called task exit landing pad. And why am I having a hard time finding this? Sorry. Something is not right with my editor today. Why? Clang D. I feel like something. Target. Okay, this is a little bit better. When a task falls off the end, it calls task exit landing pad. It then uses, it's a rare case where we use the global kernel symbol. We call task exit. Task exit, then freeze. It sort of deallocates the stuff from the task, which currently it really is just freeing the stack. And then we erase it from the list of tasks. And that is sort of the most interesting thing we're doing these days. The task list is an ETL list with, currently it only stores 2 tasks. That's my data structure, that's my linked list. And I erase the current task from the list. But in order to do so, I needed to actually patch ETL. I added this function called iterator2. Which allows you to convert a reference to a task into an iterator. And then that's what you need to call the erase API, or in general do these APIs. And so that's good. And so then I'm going to yield impl to select the next task. And then that's where we get into here, the M policy, or choose next task. And here is where this thing gets passed a task I list of tasks and then a pointer to the current task. And it can use the pointer to the current task, again using that API, to then convert it into an iterator and then start iterating over the list of tasks that exist on the system. And the implementation is not very good right now, but it's just doing this like linear time scan, looking for a runnable task. And we are using C++ iterators because that is idiomatic C++ style. But I'm Korean. Oh, the surprise Korean. Yeah, I think you posted your comment in Korean on my channel motive. Your videos bug inspired me to build my own BCI. I think that was brain-computer interface. I'm a web developer in Japan. Honestly thought I was too old to pivot, but you proved the challenge is worth it. Thanks for the motivation. No problem, no problem. Let us know how it goes. That sounds like a cool project. I don't really know much about brain-computer interface, but it sounds hardcore. Okay, so that is the current state of things. Let me just, and so, all this is gonna get mostly squashed in the end. So now let's finally dive in 24 minutes into stream. Get the break timer going as usual. So here's what's next. And so I guess doing a bit of testing would be good. So we have some nominally working code that allows tasks they can't do very much. They can yield and they can exit. and they can create new tasks. And so that's kind of an interesting thing. So maybe let's just think a little bit about what kind of test could we do. We could just have what's a really just basic way to exercise the new exit functionality. We'd have a task, and it does some stuff for a little bit. At some point, it creates a new task, and then it exits. I think something like this. And so so we're just gonna have test 0. It's going to say hello. Sort of the interesting thing is, I think I'm overthinking this a little bit. Here's what we're going to do. We're going to just have it do a little bit of work, aka just print some numbers. It says hello, prints a few things, and then it's pretty much done. And it is going to create a new task. Scheduler.create task. And it's going to Okay, that was a syntax error. It's going to reference itself. I'm going to assert that this succeeds. Task exit. Something like this. So 20 frames. Refreshing to see someone thinking through things, using their brain, getting tired of some vibe coding. Yeah, man, I feel you. Yeah, it's very tempting to not use your brain these days, but you rob yourself of a lot of things if you don't use your brain. So I was very, very tempted just to ask the AI to generate like a bit of like some tests to exercise this, but I think, yeah, I think I like just like the workflow we're just doing right now. So just the practicing, starting with a very small step, and just, even though it kind of seems intimidating, I'm not quite sure what kind of tests we need. This is probably the simplest thing we can sort of imagine. I just want to start exercising the task exit. So task says hello, does a little bit of work. It creates a new task, and then the first task exits. And so just to illustrate that a little bit, we're going to have, we have spaces for 2 tasks. And so we're going to start with one task. It's going to do some work. It's almost done, and then it's going to create another task and fill the second slot. And then it's going to create the task, but all that does is put this new task in there. It doesn't yield or trigger any change in the scheduling. It just creates the task, and then it calls exit. We're just going to deallocate it, and now we're going to have this kind of situation where, again, we only have one task. And so the linked list will now look like this. It's like a thing with only, and so now this thing is just going to go and run, and then it's just going to repeat this pattern forever. We've created an infinite loop, by the way. It's not completely obvious that it is, but we've created a sort of indirect infinite loop. And so what we're just going to expect to see is hello from task 0, some prints, and maybe I'll add a print for exiting, or I'll just log every step of the way. Created new task. Exiting. And so this is pretty basic stuff. I'm moving pretty slowly here, but I'm just moving slowly and conservatively just so we can start from very basic principles and just kind of watch this thing and just make sure it's working correctly. So we should just see these prints over and over again. Hello, 1, 2, 3, 4, 5, create a new task, exiting. Hello, blah, 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 blah. Let's just try nice and easy. This might actually go a bit too fast to see because we're not really we're not slowing things down really. So it's a bit too fast to really read, but we can kill it and just confirm that this is working. So that is the ultra basic, I mean, really embarrassingly simple test, right? But I hope it's clear what I'm trying to do. We've just added this fancy new API task exit, and we're just sort of basically trying to go for a bit of a test with it. Yeah, what else could we do? What are some edge cases we could try to test? I mean, we could... There's not that many edge cases here. What we could do is, I wish I could help you, but it's too complicated for me to understand. No problem. Yeah, not really. That's totally fine if you just want to absorb. I think I'm pretty confident I can kind of work things through, but even just a bit of just hanging out, emotional support, that's also appreciated. Vagabond, you're asking, what is the main thing that kept you working on this project? I'm just really inspired to see what it would look like for an operating system to be written in C++ and have a bit cleaner code than you see with C operating systems. I think this code is looking pretty clean. I like how this code looks. If you're writing in C, it tends to look a lot more verbose, and so I'm like, look at this kind of stuff. I'm quite happy with how this code is looking so far. It looks clean, pretty high level, and I'm just interested to pursue that vision. So yeah. Well, let's just another here's a edge case we can test. I guess I'm kind of just writing some unit tests, but what's up, Insta Headshot? Nice to see you. Here's what we can do. We can overfill the tasks. So currently we have a fixed limit on the number of tasks on the system. One thing we can just do is so we're here in test 0. We can add one more task, which is going to completely fill it up. And so if we try to add another task, so this thing is going to fail. And I'm asserting that it doesn't succeed because create task returns a Boolean. If it was based on if it was able to create the task or not. So so test 0 is occupying one of the slots. We create another task. It occupies the second one. We're now completely full. We try to add a third. It fails. And we exit, and then I guess I don't even know what's really supposed to happen at that point. But basically, we should now be able to add another task. So I think, I think I'm mostly happy with the testing we've done so far. I mean, we could have some tests that are a bit more dynamic. Okay, well, I just have, like I feel like to sort of test this, it could be useful to have some random numbers, but okay, here's what I'm just gonna try to do. I want to just fill up a bunch of tasks. I want to have them be running, and I don't know. Let's just crank the number up. Like let's have 8 tasks, and let's just fill all of them up. Let's just do the same thing we just did previously, but just have it be a bit with just like more tasks. And so, so all the tasks are running. Okay, so the interesting thing about that previous basic test we did, it was like super basic. It was just like this thing runs to completion. It creates a new task and it hands it over. It doesn't really yield. And so what we can try to do is we can have a test. They can loop to, I don't know, like 20 or something like that. And then on every, okay, I need to snooze the inline suggestions. On every multiple of 5, let's task yield. Let's have it yield something like that. Small explanation on what you're trying to test. Yeah, I'm trying to, so on like zooming out, I'm trying to test these APIs that I've added for kernel tasks, for kernel threads. These scheduler APIs, yielding and exiting, are specifically the 2 APIs we've been working on and adding. Yielding just kind of pauses the task, yields it back to the scheduler, lets something else run. And exiting like really kills a task. And so I added the APIs. We've done a little bit of testing, but not very thorough testing. So yeah, I do not have a repo, but I would invite you to, if you're interested, please sign up for my newsletter. I definitely intend to release something on GitHub, and I'll be sharing more updates around that on the newsletter. It also helps me know how many people are even interested in that kind of thing. So here's the vision. It's like we have we're going to fill up all the slots. I don't know, let's say four slots. And let's say these are the tasks. We're going to fill all of them up. And they're going to just count from 0 to 20. But every time it hits a multiple of 5, it's going to pause itself and let someone else run. And that's what we're seeing here. And so it's like this task is going to go for a little bit. It's going to hit 5. Then it's going to let this guy run, go from 0 to 5. This guy will run 0 to 5. This guy will run 0 to 5. And they will just take turns, the 4 of them, going through the list. And then eventually, the first one is going to finish. It's going to fall off the end of the for loop. It's going to, let's see, and here's the interesting part. In general, I want the system to sort of be like infinite. And so I want it to always be like running and like always filling up all the slots. Let me just finish the explanation and then I'll check the chat. And so what I want to do is, so in the case of after task 1 is done, I want to make sure we always have all the slots filled. And so in this case, there's no more slots. It won't be able to allocate another one. So it's just going to die and get out of there. And then, so now, now task 2 is going to finish. And it will be able to fill another slot. And then it's going to die. And then task 3 is going to finish, and it will be able to fill another slot, and then it's going to die. And so in general, I'm envisioning something like this. We're going to have, I guess we're just going to call the API and then maybe can fail. Create task, which may or may not fail. It's going to just try. Task exiting. So also one thing I want to do, it would be nice to be able to reference the current thread ID, like, and how would we do this? I think, let's just refresh a little bit on the data structures. Task.hpp. Task.hpp. So threads have a task ID. So I think, and we can just get it like this. Let's make sure to print it at all cases. Okay, let's hello from task. Sometimes the AI suggestions are good. So all these prints are now going to print the current task ID. And I want to really slow this thing down a lot. So I'm just going to add it even knew what I wanted to do. I'm going to add a really big loop here on every iteration. So let me see. Oh man, what's the chat? Chat was going crazy. Man. Yeah, please do not spam the chat, by the way. UI is the least interesting part to me. I probably won't get to it anytime soon. So here's what I expect to see. We're gonna, we're still just running task 0. Well, what I was thinking about is it's probably safe to do this, right? We had the current task, we had its ID, and we save it into a local variable on the stack, and that should be nice and stable. So what I'm expecting to see, hello from task 0, then 0, 1, 2, 3, 4, 5, and then it's going to hit the yield. Then hello from task 1. I'm even thinking of running this in the debugger so I can just have a bit more control over this. Let's just whoa. Failed. I'm gonna break on. It is annoying. Task yield. I'm just gonna press a breakpoint there. So let's just continue. Good. The task 0, technically, I guess it hit this thing. Okay. So as we slowly watch through task 0, 0 through 5, and now we're stopping, we're hitting the yield. Now we're going to switch to task 1. So that did not work like I thought. Okay. We kept in task, let me just, it's interesting. Oh. Cool, okay, so clearly I missed something because we're not really switching. This is interesting. It's hitting the yield, but it's not really, it's not switching to another task. And so clearly there must be some thing I'm doing wrong. Let me see if I can figure it out. I know. It's because I forgot to fill all the slots up. I only had one task. So every time there was no other task to run. That's why. Now let's try that again. I think that was the problem. LDB kind of hangs. If I close, oh, that's annoying. LDB hangs a little bit if I close the something too early. Classic. Okay. Yep. Okay, let's try this out. So, yep. So each of the tasks are going to hit on the very first iteration. They're all going to yield, and so we go through the 0. They all yield, and then now the third one just yielded. So now we're going to go to the task 0 and do 1 through 5. Bam. We hit the yield, and so now on the next turn, it's going to be task 1, 1 through 5. There we go. Then task 2, 1 through 5, 3. Okay, so that is looking pretty good. That's looking pretty good. And now task 1 does the second round, up to 10, up to 10, up to 10. Cool. Again, up to 15, 15, 15. And then here's going to be the last round. So when I... but let's first feel free to join me for a 20-second break to stand up and stretch. Be right back. Okay. No push-ups today, too tired. It's all right to take a rest day sometimes. What's up, hello code, by the way? Are you at the trap handler? What's up, endpoint? No, I'm not. We're just testing the basic cooperative scheduling APIs of the scheduler right now. So now let's think about what's gonna happen. Okay, so we're at task 2. Let's do it one more time. Task 3 is gonna run to 15. So then here's the interesting question. What's gonna happen now? We're gonna go back and enter we're going to return from the yield on task 0. And we are going to print up to 19. We're not going to print on 20. We'll print to 19. And we will fall out of the loop. We are going to try to create a new task to keep all the slots filled. But that's going to fail. Because they are currently all filled. There's no more available slots. So I'm expecting this is going to print 0, did not succeed. Then it's going to say task 0 exiting. It's going to hit task exit and then hit the breakpoint. Let's see if I am right. What happened? Create task succeeded. So I'm wrong. Somehow I'm missing something. It succeeded in creating a task even though all of them were full. On task 0. Let's understand what's going on. Chat popping off today. What's up, Digitalized? Nice to see you. Julius, what is this program? Can you be more specific about what you're asking about? This is, in general, this is my operating system. Yeah, chat is active because of VA80, of course. Of course, best chat activator around. Samud, could you recommend a laptop? Unfortunately, that's totally not my area of expertise, but maybe someone in the chat can help you with that. Okay, back to struggling. Why did this succeed though? Why did that succeed? My expectation was, okay, here we filled up all 4 slots, and this thing, I'm just gonna ask it to make a new chat. Wow, it's kind of slow. Oh, interesting. I'm gonna get the sonnet assert all these succeed. A bit of grunt work. I'm trying to. Whoa! I exceeded my premium request allowance. Crazy. I'm on GPT 4.1. Like, dang, I got downgraded. Okay. Let's try that one time. So, okay. So here's my expectation. There are only 4 slots available. Oh wait, I'm stupid. I put the numbers 8. Let's change that to 4. That's why. Okay. Oh my gosh. The LLDB hang of death. Okay. One time. Okay. So let's just speed run. Okay, I think that was it. Or no, I went a bit too fast. So there we go. Task 0 gets to 19. It drops out of the loop. It fails to create a new task because they were all filled. It exits. Task 1 picks it up and finishes its iteration. It is able to create the new task. It exits. They all do the same thing. And then task 4 begins, which is sort of a whole new generation of tasks. All of the original first generation of tasks has exited at this point. This is task 4 is a new generation of tasks, and it's starting its own thing. So we can, how do I, oh my God, break. How do you disable a breakpoint in breakpoint this? Okay. So that's sort of, so that's what's going on. That's our OS. It's doing tasks. It's doing tasks. That's pretty cool. The tasks are switching back and kind of between each other in the typical round robin fashion. They're counting up in 5 increments each, then switching to the next. Then when they get up to 20, it pretty much they're all succeeding now because there's all like there's sort of just always one free slot now for them to create a new task into. So yes. So that's looking pretty good. Are your tasks hard-coded tasks because you're testing? Yes, I am very much testing right now. Yeah, very much testing. In real life, in the kernel, I'm not quite sure how it'll look, but it's going to create a task for what's going to effectively be like the main thread or like the init process or whatever it is. Something like this. What's up, Wall Markets? Nice to see you. What do you think about Terry Davis and his OS? I think Temple OS is a cool OS, and actually I'm pretty inspired by it. Mainly, I think Temple OS runs entirely in kernel mode, and that's very much part of my approach. I'm really deferring user space to way in the future. I'm not planning to get to user space anytime soon. I'm planning to just do everything in kernel mode for a very long time. So that's something I was inspired by from Temple OS. Like the Kirby mascot. Oh, for sure, we got Kirby out here, definitely. Now the tasks need threads. So yeah, so like these are threads basically. The tasks, like task and thread is sort of like a, I think I will probably rename task to thread in production. But yeah, just for fun, I'm going to remove this big loop, and then we'll just see how fast this thing can like really rip, because it's going to go way faster. Yeah. And it's always an interesting question when you see numbers getting big. It's like, what type are you using for that number? I'm using a size T, which means it's 64 bits, and so it will pretty much never overflow. So, but if I used a 16-bit int, we would already be overflowing the task ID here, because so that's cool. We got our ultra basic task switching going. And what's kind of cool is you can also see that it's kind of working, because like all of the execution state is being saved and restored. Like the stuff on the stack, it's all being saved and restored. So that's cool. Pretty happy with that. I'm gonna take a screenshot for the museum. It works. Switching between 4 tasks and then exiting and spawning a new task. So we'll go ahead. No, wait, what am I doing? We'll go ahead with the pen tool and my pen is kind of skinny. Okay. Never mind, we'll go with the star. Test it with a bunch of threads, test it some more. Okay. Does it make sense to use artificial intelligence when writing a kernel? Yes, absolutely. Artificial intelligence is very helpful when writing a kernel. Kernels are so confusing. It's really nice to have an expert in computers to help you with that. Why are you using Miro and not stuff like Notion and all of this? Using it because it's a really nice visual tool. I don't think you could do any of this in Notion. So, yeah. All right, let's move on. And a couple of things we could move on to are move this forward. The idle thread, some of these things. Let's do the idle thread. Basic test for tasks, switching and exiting. Okay. So now let's talk about the idle thread. Because the real question is, what happens if there's no tasks available to run? In the strange case that happens, let's say I just don't have any tasks and I try to start the scheduler. What's going to happen? We're going to assert. We're going to assert right here on the yield impl blah, 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 blah. I'm going to assert right here when we try to choose a next task and we can't find one. In general, that is bad. If there are just no runnable tasks, we don't want to assert. We want to at least be running something. And I think that's where, again, back to not eat, we'll leave in some time. All right. All right, what's up already, Mystic? Yo. Let's do a quick check-in on the stream health. Cool. All right, we want to make sure. Seems like you haven't updated your visual code in a long time. Why? What makes you say that? Do I have a really outdated VS Code or something? I think I updated it fairly recently, but I don't know. Okay, let's talk about the idle task. And so I want to make sure that there is always a task. Latest update has all new colors. I think I have a custom color, like custom colors, so that's probably why. I mean, I think this is pretty easy. To add an idle thread, idle task. Why are these things inline? Oh, because we're in a header file, that's why. I'm not talking about UI colors. Oh. You're talking about what? Like syntax highlighting colors? So the idle task is just going to be a really simple task that just always spins. And it doesn't do anything. And oh, interesting. I mean, you can change the syntax color scheme. All right, so I think, I mean, for the idle task, all we do is we just idle task. We just always make sure to add an idle task to the scheduler. Huh, but I wonder if that should be necessary. So this is one way to solve the problem. We just require that the client of the scheduler adds an idle task to manually. But what if the scheduler just internally did that? That might be kind of convenient for clients of the scheduler. So So that can be an option. And what would that mean? So that would just mean maybe in the constructor, yeah, I think we would just add some kind of idle task here. So detail. I'm just gonna have an idle task here, I guess. And I think there's, I mean, we can assert stuff all day, I guess. Yeah, I'm just thinking about the API design. Like, it's pretty cumbersome to add all these asserts. It might be interesting to have an API that's like create task and then try create task, and then create task actually asserts or something if it wasn't possible. But I don't know. For the moment, I think this is fine. And so basically what I'm just doing is I'm moving the responsibility for having the idle task from the client of the scheduler into as an implementation detail of the scheduler. And now if I do this, if I just don't add any tasks at all and then call scheduler.start, we should just see an infinite loop when the idle task runs. All right, 20 seconds, be right back. Goated, fine. What's up? So yeah, we just see that. Oh wait, no, it's asserting actually. Why? What? Scheduler gets constructed. It creates a task. Why is it asserting? So this, it's the policy was not able to find something. It's a little bit wasteful to have a stack frame for the idle task. Okay, something does not make a lot of sense here. Why is that asserting? Oh, dang. Let's just break here. But I guess I already missed it. But we can break on here. Step into this. We step into choose next task. The task is marked not runnable, but that's but then we mark it as runnable. So there should definitely be a runnable task. Is that true? There should be one. Let's like step through it. So, I mean, let me just, okay. Okay. Okay, I see what happened. P task was null pointer. This was the very, very, very first schedule. P task is null pointer, and so it just selects. It goes and finds the first one. So now it's switching into the idle task. So I actually don't. I need to see that one more time. Schedule. So, P task. If we don't have it, the start gets set to the beginning of the tasks, and that's why we end up here. So I think that's what we should happen. Yeah, we're here. It. Ismail, what is up? Nice to see you. Hope you're doing well. We have been making good progress in the meantime. This is so interesting. What? I'm trying to get a pointer to a task in this linked list. And so that worked. And so we switch into the idle task. Oh, I see. I see what happened. I need to have an infinite loop. The idle task was just this dumb thing. There we go. Now we have a functioning idle task. It was formerly exiting, and the idle task, that's the one job. The idle task just should never exit. It should just always just sit there and just be runnable. Okay. So perfect idle task behavior. And let's see. Oh, y'all are finding my new chat commands. I made a Rust command just because a lot of people have been asking me the same question. So, funnily enough, we have not had anyone ask that question today. But if someone pops in the chat and drops the question, y'all know what to do. Y'all know what to do. Hit him with the bang Rust. Okay, so just to do a bit of a test here. So now kernel.hpp. So let's say, but I hope it was clear what I did there. So the initial just like idea was just to always do this outside the scheduler. But if we just take one more second to think about the API design of the scheduler, it might be pretty frustrating if you're very new to using the scheduler class and you just like, you forget to add some tasks and you call start and then the thing asserts. I don't know, maybe that's good because then you know about this, but then you also need to go through all the effort of manually adding your own idle task, which is like very cumbersome. And so it's sort of convenient that the scheduler already handles the idea of an idle task for you and doesn't, and you just don't need to worry about handling that yourself. It's a trade-off between just being very explicit and kind of the verbosity of what it looks like to be a client of this API. And I sort of tend to want to be less verbose for clients. It's just, yeah. In general, it's just something we just want to have. And so I think this is a good idea. I'm going to add back the test 0. So now we can do a bit of a test here. But maybe I'll rename this to make a new test 0 for myself. What I want to do is actually no, I realized there's another issue. This thing just currently, yeah, this thing needs to yield. It should be a yield loop. But now it's a bit unfortunate because now we are actually using, I see. The scheduler should really not depend on the kernel. And that's actually kind of a problem. If we include a complete, if we include a completely full functioning idle task baked in out of the box with the scheduler, we can do this actually. Yeah, so it needs to know the kernel, but what we can actually do is maybe we can optionally, so right now tasks always, all right, I'm gonna eat now, get back to you, happy OS dev, thank you VA80, cheers. Are you writing unit tests for your scheduler right now? Not exactly. I'm still manually testing the scheduler, and I'm manually testing it with these kernel tasks that do different scheduler things. Unit tests might come later. The tricky thing is the scheduler is probably one of the most difficult components to unit test, because it does this really low level, like assembly level, like switching of stuff, which is not very compatible with like unit tests. However, I've architected it such that the scheduling policy lives in a different component, and that is completely unit testable. And so I'm pretty happy about that. So we will be able to write, I'm pretty sure we can write pretty comprehensive unit tests for these scheduling policies, but the core scheduler itself is a little bit tricky. And so even once I finish my manual testing, it probably will be difficult to actually unit test that. Yeah. How do you handle hardware compatibility and drivers at this stage? So I don't do either of those things. I literally don't have any drivers because I'm not interacting with basically any hardware at this stage. I'm focusing on core task, like computation task switching. And I also have not really thought anything about hardware compatibility quite yet. So what I want to do, so we have this problem. So we have a problem, right? So number one, I wanted to offer a nice, easy, out-of-the-box A+ API experience for users of the scheduler class, which means providing a nice built-in idle task. And so a client, such as the kernel, never needs to worry about creating its own idle task. The problem is that the idle task needs to be infinitely looping and yielding in a loop. And that's a problem because tasks currently always receive a kernel reference. And that introduces a dependency. If I want to have the idle task calling yield, I need to get to the scheduler. I currently need to go through the kernel. It's a problem to introduce that dependency. The scheduler really should not know things about the kernel. The kernel owns a copy of the scheduler, and the scheduler shouldn't really know that it's contained within a kernel. And to solve that problem, I want to be able to pass a scheduler reference into this task, and not a kernel reference. And so to do that, I might adjust this API. I might say p context, what is it, null pointer. So yeah, we need the comma there. Update function declaration. Okay, I need to not do this here. I need to something like this. So the scheduler already takes a MP context to pass to threads, which is where this kernel thing comes from. But I'm giving here the idea is to give the option to a task to have a custom context, which is basically only used for the idle task, because pretty much every other task on the system is going to want to receive a kernel reference, but the idle task is kind of special. And so the idea is that here's where we choose the context. And so if we have a p context, we're going to use the p context. Otherwise, we pass. So here's where we're setting the state for the RDI register, which is the register that contains the first argument of a function call. And normally, we're passing this MP context, which is what the kernel passes in. It's this pointer to the kernel. But in case there was a custom context, we're going to use that instead. And that should solve our problem, because then we can have okay, this is where my coding is getting a little bit sloppy, but the idea is that we're going to be able to say scheduler. Oh, interesting. Oh, okay, this is so scheduler tease, scheduler policy, scheduler. So now we have removed the reference, the dependency on the kernel. But now there's this other unfortunate situation where this thing is depending on the scheduler. What the? Okay, I thought I was being very smart here, but I am sort of tying myself in like this weird knot. Okay, I tied myself in this knot because I forgot that the scheduler is a template class. Which means the idle task can't just simply depend on the scheduler. It needs to depend on this scheduler with the policy. Here's an idea. Idle task. Here's an idea. Static void idle task. Task yield. So then what's going on here? Right. Task yield. Okay. I think I untied myself out of that weird knot. Yo, what's up, Indie Whip? Nice to see you in the Twitch chat. I think I untied myself from that weird knot. The weird knot was like I was trying to make a function. Like normally these tasks are functions. They're just like free functions. I was trying to make it a function that takes a scheduler. But I forgot that schedulers are templated classes. So I needed to make this function a function template. But that means that you can't just create a function pointer to a function template because it needs to get instantiated. And the way I have solved this, I will explain after 20 seconds. I'll be right back. Okay, so that was a weird knot. The way I solved this was by making the idle task not a free function, but a static member function. And the reason this solves the problem is because then it sort of gets associated with the templated class or struct itself, and then we're able to more easily use like it's all sort of one unit basically. And because it's a static member, it sort of behaves like a free function. And this then becomes in the private section because it's not like a public API. So, except I need to do this correctly. I need the while loop. Okay. Cool. So we got our idle task. So no matter what you instantiate the scheduler with, we're going to generate an idle task for that scheduler policy. And that's how we're going to do this idle task business. There we go. Okay, cool. What's up, Grab Joshi? How did you get good at C++? I got a job as a professional C++ developer. I think that has been by far the contributing factor. What's up, Replays? Do you use AI? Yes, I use AI. Bro, just use Claude Code. Sounds good. So we got our idle task now, and I sort of like that. So now clients are like pretty easy, pretty minimal. They don't need to worry about the idle task. That is automatically handled for them in the scheduler. And yeah, then they can just do nice, clean stuff that they want to do, and they just don't need to worry about ever like asserting on that. Let's just test this. Let's take this for a quick test spin. So if I just have no tasks and okay, okay. What duplicate symbols? Okay, I was doing some weird things. Okay. No fault. What? What? Oh my gosh. So... Do I regret taking that job? No, I don't. It's a good job. Are you building Windows 12? Yes, I'm building Windows 12. I do not have any kind of user interface. I don't even really have a terminal interface. The OS has no form of user input right now. I just haven't done that yet. The OS only, it's like an output only system. I can only output things. I have no way to take in any kind, like no like no text, no terminal, no serial console. I got nothing right now. I only have output. So that's the extent of things. Chat's popping off today. That's true. We got an active chat. Dang, 42 people. Also, is a good number. Chat's popping off. This is the demo of the OS. I mean, to be clear, my OS is crashing TF right now. Okay. Let's see about that's really freaking annoying. I was really hoping this would be a nice easy thing. So first off, if I remove this line, we should get the assertion failure. There we go. So that's a nice safe assertion on not being able to find. Oh wait, but I see. Okay, so now, wait. There. Okay, I think there we go. We need to remember to pass this to this idle task. Because our idle task is doing this unusual thing where it's not taking the current, like the default argument that tasks normally take. It's using this custom API to take a special first argument. I was forgetting to do that, and so actually what was happening is the idle task was receiving the kernel reference as an argument, and then I was trying to like improperly use it. So let me just try that one more time. So there we go. That's exactly what we want to see. That is exactly what we want to see. Our nice little idle task is running. We can hit the Control C and see that we were in the middle of a schedule, and I can even break on something like scheduler task yield. And we can just see we're just constantly breaking on this thing. It's just being called in a loop from the idle task. So it is very anticlimactic because it's literally not doing anything, but it's providing a nice stable layer just in case there are literally 0 other tasks able to be run on the system. We can always just fall back on the idle task. Oh my gosh, chat be popping off. We got a lot of Terry Davis discussion today. Are you the next Terry Davis? Bro, are you inspired from Terry Davis? Bro, look up Terry Devise. You are like him. Wild mods. Why VS Code? I just, I'm familiar with it. I like it. It has a lot of nice extensions. And I think it's a pretty nice editor. It works pretty well out of the box without so much configuration. So I do like that. There's a nice little Panic at the Disco for sure. Is this code committed somewhere? GitHub? Check it out. Vrutab. Unfortunately not. I haven't released anything yet. But if you're interested in hearing about updates about a GitHub release, I would invite you to sign up to my newsletter where I'm talking about, I'll be posting updates, and also that helps me gauge the interest in it. Garden OS is the new Temple OS. Ismail with some rare terminology. What is Garden OS? Yes, what is the Garden OS? Only people that have been around for a long time will know what that refers to. Learning Lua for Roblox. I don't know Lua. I barely know what Roblox is. Hello, sir. You teach me how to build like you. I can link you to my resources page, and you can also join the Discord if you want to chat some more. I feel like I'm leaving out. I'm sorry, Indie Whip, for lacking for not checking the Twitch stuff I see been posting. Lua is like Python. It's like the scripting language that's very embeddable, I think. Indie Whip starting on the Raspberry Pi OS. VS Code is awesome. It is simple. Indie Whip, I got to a point where I've finished my OS. It's fully functional, but still got some bugs, but I ain't tripping. Yeah, never be tripping. Never be tripping. All right. So let's check in on the progress update. Idle task. Let's also, can we choose a more inspiring color for this? Got the orange. Idle task. Pretty much done. Let's just take a quick review of the so the conclusion was this is the diff. This is the diff to support the out-of-the-box idle task. Probably some documentation would be good. All right, let's just document things real quick. I don't know why I'm doing that. Is this thing? Okay. Let's just go with normal comments. I'm just going to say for now, automatically includes an idle task. Context to pass to threads is a pointer. Passed to all tasks. Cool. Let's go over here. So create task. P context. This is actually a pretty good comment. Oh man, we got the juicy question. Why hate MV? Why do you do this when I can make a notice in a few days? Let's see, what are people saying about that? How can you learn the intricacies of OS if you delegate it to the AI generators, which aren't 100% deterministic? It's probably bad for OS type code. Takes away all the fun. Good answers. Yeah, I can do everything. I'm saying, what's the point in learning OS dev? What's the point of humans? Oh man, yeah. I mean, the point is to understand. The point is not just to have an OS. The point is to understand how it works, and you don't get that. Yeah. So sorry, Kamikaze. I don't quite understand your question. Could you maybe rephrase that for me? So we've got some create a new task that will begin execution at task func. Returns false if task creation fails. Good. So we got a pretty nice scheduler class. Got some comments, got the custom P context, got the idle task. I'm really happy with this, I have to say. I'm not sure if it's super visible on screen, but like, I'm very happy with, man, that mangled it. I just want to point out this code. I'm very happy with how this code looks. I think this is really a great example of C++ producing code that is quite nice to read. Like, I'm just going to ask AI, what would this code look like in raw C? Would it be less concise? I just have to, like, what are we doing? We're allocating a structure, constructing it in place at the end of a linked list, and also customizing the construction of our task register state with a couple registers. Let's see. I mean, I'm very much biased to the AI. The C++ code uses features like constructors, member initialization, templates, and a placeback for in-place construction in a container. In raw C, you would not have these features, so the code would be less concise and more manual. Here's how the core logic might look in C. Yeah. Make a new task, set like a bunch of things on it, do all that stuff. So, yeah. C++ is not perfect, but I have to say, I'm happy with this. I think it's quite nice. The task register state gets default initialized to all zeros, except for the things that I want to specially initialize. And see, I think even the AI even made a mistake here, actually. Not completely a mistake, but one difference between the C++ code and this AI code is the task is copied here. Pretty, like, it's pretty clear that the task gets like copied here, basically. And in my case, the task gets constructed in place in the linked list. There's no copy. So that's pretty nice. Okay, we got some dissenting opinions. We got James out here who prefers the C code. And that, you know, I mean, that's fair. People have their own opinions. I think I'm a little bit my brain has been sort of morphed into C++. So I think this looks nice. I like that there's no mutation. I'm not constructing a thing and then like mutating it to get it into the right state. I just specify all of this without any mutation. I quite like that. I think all the angle brackets belong in Java. I see a bit of triggering around the Java. C plus neat abstractions. Nirajan Data. I'm on C++ 23. Yeah, work with what you're familiar. True, yeah. So for me, I mean, basically, this is the kind of code I like read all day, and so for me it feels very familiar, and I just sort of like the pattern. Okay. Man, well, that was kind of a cool set of progress. What did we do? Did quite some extensive testing with the with our kernel threads, with yielding and exiting, and that seemed to be working pretty well. Got our idle task working, and stacks don't run out of the fizz map. I wonder if we can knock that out really quick. I mean, first maybe let me just so we don't actually need some of this stuff. Yeah, okay, cool. Oh, already. Okay, I'm just gonna kill the palm tree. All right, Kamikaze Jester, did you ever try writing code with malloc or realloc? Yeah, I mean, to be honest, I haven't done like a massive amount of coding where I'm calling raw malloc because I haven't written like a tremendous amount of C applications, which is why I'm using C++ and not C because I don't really know C. So yeah, mostly I guess so. Not really. I haven't done like a tremendous amount of like malloc realloc. I've done like a bit of it just for learning, but I've never delivered like a big application that was based off of like malloc and realloc. Okay, so let's see if we can just knock out one little thing. Stacks don't run out of the fizz map. What are we even talking about here? I think I had an example at some point. Yeah, here's the example. So here's what memory looks like in the current implementation right now. When we make threads, I'll just illustrate a thread over. Let's call these threads. When we make different threads, they each get their own stack. But I did it in a way that's kind of bad. I wonder if I can just move this all down. I chose the lazy route. So I allocated a physical page. We allocate a physical frame for our stack using the bitmap frame allocator. And then all that does is allocate a physical frame. It doesn't necessarily live in virtual memory yet, so we can't necessarily like use it. But the reason I say necessarily is because it actually does, because everything lives in the fizz map. And so the fizz map is the easiest way to just access like arbitrary physical memory, because everything is just mapped in the fizz map at all times. And that makes it really convenient for just like prototyping, which is what I've been doing. So I allocated my stacks, and instead of doing the actual responsible thing of then allocating them in like actual virtual memory, that's not the fizz map, I just located them within the fizz map and then used that. But that's really dangerous, and you don't want to be doing that, because the fizz map, if you start using the fizz map for stuff like this, you give up all of the memory protections of virtual memory, because the fizz map is just this massive read-write space of memory, and there's no memory permissions in that space. So that is a major disadvantage, and it can be kind of dangerous, because what if the task runs off the end of the stack? Usually you would have a guard page that would cause a fault and crash things in some kind of way, but you don't have that with the fizz map. If you go off the end of the stack in the fizz map, you just start corrupting random memory, and you have no idea what is allocated below the stack. It could be very important data, you just have no idea, and so it is really poor hygiene to run out of the fizz map. Don't tell me not to do anything dangerous. Yeah, and so I'm just saying, okay, in my kernel, more hygienic way to do things is to do it this way. We actually allocate some v address space for it. But let's just think about what that would involve. Okay. Quick aside, I was just thinking a bit more about this thing with the whole chat AI, whatever. I think this is actually not a completely fair comparison with what I have over here. So first of all, it assumed that mtask is an array. So it is copying into, so there's absolutely a copy here. I think the equivalent code on the C++ side would be if mtasks were a vector. And in that case, the mplace back would mean we don't do the copy. So I think that's a fair point. I think things change a little bit. Mtasks is not a vector, it's a list. It's a ETL linked list. In that case, that changes things a little bit, because in that case, you wouldn't be copying into the list. It would be like some intrusive list. And so you would just populate the struct once and then just link it into the list without any copies. So yeah, anyway, let's get back to, I'll check the chat in a moment, but basically here's what I was talking about. Here is the big hack. We get the physical address. We get the physical address, and we just use the fizzmap adder converter to convert that to a virtual address. And the question is, how could we do this better? The answer is we probably need to start using our v-address space class, which first made its appearance several months ago when I was prototyping all this stuff, but then I never actually used it for anything. I have not actually used it for anything. So this would be the first instance of using it. And let's just think about that. So our scheduler, let's just say we're going to store a address space reference. I'll call it a V space, which I think sounds kind of cool. So we add, okay, the AI knows what's up. We need to, or not, I'm just going to, sorry, find. Going to depend on the address space, the HPP. And the problem, wait a sec. Okay. So we need to, so that this is actually impacting quite a few things. I need to add this. Okay, this is interesting. So the AI, it sort of knows what's up, except it's a little bit wrong for the final thing. There's no PML4 table base. Let me, so how are we going to do, I think what we're going to do is I need to call x86.h CR3. The code, let me see the code. Sorry, the code. There we go. Okay. Read CR3 64-bit. I think I got, yeah, okay. Please generate a 64-bit version of this. I need a 64-bit version of the read CR3, and I swear I just refuse to learn inline assembly. Cool. I'm just going to trust that I got this right. And based off of this old diff of how I was doing it, we just pass in a read CR364 over here. And so CR364. Man, chat is really popping off. Whoa, guys, dang, 65 people in the chat. That's crazy. That might be one of my records even. Dang, I was too busy trying to do some programming. I will get to the chat in 1 second. I'm just trying to flesh out a little bit of this final stuff. And so the idea is to yeah, VA80, I take all the credit. Yeah, chat started popping off on VA80. started showing up. Okay, so I'm just trying to get my v-address space going, and I think this is like sort of, do I have an include? I need to add space. Is it v, wait, okay. The address, that's confusing. The address space. But the thing is a v-adder space. That is confusing. So got the v, and we are constructing it or passing in the passing in the CR3 of whatever the context was at the time, which I guess that is that might change. That will probably change if I had to guess, but that's totally sufficient for now. We're just going to be using the CR3 that came from Limini. And then we pass it to the scheduler. Why is my IntelliSense broken? Okay. Because I need to type the file names correctly. So let me see. Right, so now over here I can jump to the scheduler. And we have our v-address. So this should compile. I'm just gonna try to compile, not run it just yet, but this doesn't even compile. Oh, what's going on? Redefinition, that's a bad sign. That means I forgot a pragma once. Try that one more time. All right, so we are building. Yo, 76 people in the chat. It's crazy. We're popping off right now. It's a party. Okay. Yeah, so it's compiling, which means we're now able to use the v-address space. What's the usual viewership numbers? It's probably like 20. I want to say we've been getting, like, on a good day it's like 20 25 maybe. So yeah. Let me just lock in for like one of the final things of today. So we have the v-address space. It's constructed in the kernel. The kernel passes it into the scheduler. The scheduler is now able to use it. And yo, James with the donation. Okay, I need to make sure I add that to the, you know the rule. Everyone knows the rule. If you make a donation, you get added to the Miro, and you get a star. Thank you very much, James. We got added to the list. Yeah, it's got to show off the museum. Wall donations, Mohit, I Am Gods, VA80, James again. That's the rule. Make a donation, you get added. You get added to the board. Thank you, James. Yeah, time to not crack under all the pressure of like 100 people watching me as I don't know what I'm doing. But so now we have the v-address space. We can use it, and here's how we're going to use it. Let me make sure I drop a comment for James's donation. So here's what we do. We got our v-address space, and the v-address space is going to be our kind of alternative to this big hack of directly using the fizzmap adder converter to get a virtual address. Instead of just simply converting this physical address to a virtual address in the fizzmap, we are going to remember how the hell to use a v-adder space and try to do that. And so it's going to look something along the lines of mv-adder space. Oh, whoa. Okay, I'm going to snooze the inline suggestions for 5 minutes so it doesn't give me the answer. We're going to call map, and then here's kind of the hard part. We need to choose an address. Yeah, what okay, here's the hard part. The map API, we need to choose an address to map it to. We can pass in our physical address that we got from the physical memory allocator, but we also need to tell it, okay, where it's like, okay, I can map it, but where do you want it? And gonna change names to online mark. Yo, 92 people in the chat. What's going on? Man, y'all are boosting up the chat like crazy. This is wild. I just gotta stay calm. I just gotta stay composed. Stay cool as a cucumber. Me throws a palm tree at the screen. Honestly, that's a good call. I'm going a little bit over time here. Let's take a quick palm tree. You know, I just had the thought, historic stream. I just had the thought, while I was thinking of numbers, I just want to make sure everyone knows that I'm doing social media now. And so if y'all are I'm doing short form content. And I've been posting just stream clips on Instagram, TikTok, and YouTube. But this one kind of popped off a little bit and got a bunch of views recently. And so if y'all want to help me out and follow me on socials, that would be cool too. I mean, you're all here in the stream right now, and so basically like this is not new content for you if you're seeing this, but yeah, I've been doing the short form content. Okay, lock in. So basically, the thing is that we just need to decide where we want the stack to go. And Thank you, VA80. Appreciate that. Let's just think this through. I think we're missing something, and so I think I sort of need a memory allocator. I've really been trying to avoid writing a memory allocator or having a dynamic memory allocator. But how do I choose? It's like the question is, what do we pass into this thing? And that is the job of a virtual memory allocator. It's like you give it, I want you to say, I want this amount of memory. The thing is like, all right, you got it. Like, here's your spot in virtual memory. And I think I have an idea about how to hack it. I think I have an idea about how to hack it. Instead of, we could just store it. We could store space for the stack in the actual task, which is kind of a very strange thing to do. So currently the slots for the tasks live, they're allocated statically in the kernel, because I'm using this static allocation approach. So as a refresh, the scheduler stores a task list. A task list is an ETL list of 4 tasks, which means it pre-allocates all of the memory in this like potentially like a large object. And it stores that directly in the scheduler. And right now a task is a fairly small structure. Yeah, this is like a really stupid idea. But an alternative, this is like such a stupid idea. An alternative to having the memory allocator would be to store like seriously, like, I mean, it's something like, stack, basically. And that would allow me to like punch this off, this whole topic off. But there's a lot of reasons why this is a really bad idea. But I'm just gonna try it anyway. This is like, what I'm doing right now is a little bit like, I don't know if you know the show Jackass from MIT. This is like MTV. This is like a little bit like Jackass programming right now. Align to 4K, please. I'm gonna allocate a stack inside the task itself and align it to 4K. This is an awful idea because basically it introduces, it wastes like 4K of memory in this gap between these things and this thing. Is that able to move in the corner? Yes, it's able to move. Okay. Awful idea. So, okay, just so the record is straight, this is an awful idea for a lot of reasons. So for one thing, it completely blows up the the size of the kernel. Like, we have about 2 gigabytes of space in the top region, and so it's not really, I mean, a critical concern, but it potentially would be. And so it blows up the size of the kernel a lot. It wastes like a ton of memory for the padding between here. But the key advantage, and why I'm even considering it, is because let me see. I think I'll need to do a little bit differently. Actually, wait a sec. So the idea would be we get the physical pointer, we call map, and we point it at the stack for the current task. The problem is that we don't have the task yet. That kind of sucks. Or wait a sec. Whoa. But we have it here. So let me. Okay. For the task stack top, we derive a few things from it. We write something into, that's fine. And then we set RSP to the stack pointer on task entry, which is derived from this thing. So, and that is the problem. It's like I'm trying to conceptually do something like map task.stack page frame, basically. I don't know, this super huge comment. This is like conceptually what I'm trying to do. I'm trying to make this, it's like, I guess it's a pointer. This thing point, like this memory should point to this physical frame. The problem is we don't have the task yet. The task gets created here. Like all that C++ stuff about how it was so great to just like construct it in place, that is sort of getting in the way right now because we just don't have the task yet. Oh, the TikTok was background music. Okay. Let me, man, okay. All right, so let me just in place back. What does this return? It returns a reference. And so this is like maybe doable. And so again, fully in the world of like awful hacks, but just to prove the point of what is possible, we create the task, and then we need to reset. I'm going to snooze the inline suggestions for 5 more minutes while I can type this out. Point map the stack to point to the pre-allocated one, reset RSP to point to that. And so and this is probably some type error, right? So we need to. So this is like a char star, and so we just need to cast this to a void star. And I'm just being kind of lazy. But wait, no, it needs to be. Memory types. It needs to be a v-adder. and that accepts of UN64T, so it needs to be UN64T. And then we can take task dot register state dot RSP. Equals, and this is going to be pretty ugly. So let's whatever. So I'm just gonna do it in line. So it's this thing. We're gonna convert that to a char star. I think it is a char star. But just to be safe, char star plus k page size minus size of void star. Basically, size of p, this thing, right? It's almost, and this thing all gets casted back to UINT 64T, right? So to be very clear, this is not production code. This is just sketching it out, but I'm sort of just replicating what I was doing up here, where we had some base, we add the page size, then we subtract the size of a function pointer. So we have this base, we add the page size, we subtract the size of the function pointer, and that gives us the final RSP state that it should be. Do not use this code, to be clear. So I think that is actually it. And so what I'm doing now is we're no longer, and so now with this change, we sort of get rid of this thing. So we no longer really initialize RSP. We don't need to do that, because the place we're initializing RSP to is here after we map the stack. Yeah, this is like a very odd, this is a exceedingly bizarre idea, but that's my quick hack for just like sidestepping the need to have a memory allocator that like allocates up this space and stuff. I mean, it probably wouldn't have been so hard to use a bump allocator, but we want to be able to free these things, these stacks, and so a bump allocator is not really suitable for our needs. So yeah, let me just see if this builds. I just actually ran it. So now to test if it works, and this will be one of the final things we do today. In this historic stream, let's go back and add this thing we were doing. If there isn't a hack comment, it's not ready for prod. We got 4 tasks, and we fill up all our slots with a test and this is our test task that's just going to announce itself, count up to 20, but then schedule every single time. And then at the end, when it's done, it'll try to create a task and exit. If it can't do that, I'll add back this leap, just because we're testing. I will run this in the debugger. I'll break on task yield. Oh, interesting. the assertion failed because of the idle task. And so we tried to add 4 tasks, but a slot is reserved for the idle tasks, and so we really only have 3 available. 20 frames. The 4 kilobyte stack inside the struct looks risky. That's why I have the comment says awful idea. Yeah, it's a very, very sketchy idea. But I'm sort of stunt coding right now, admittedly. So, but also not. This is genuinely my strategy for just moving forward as quickly as possible and not getting bogged down in things like memory allocation as long as possible. Okay, so cool. 3 tasks, task 1, task 2, task 3. How is this looking? And I think the idle task is getting a turn every time too, which is interesting. Because it doesn't really need to. I think the round robin scheduler is sort of naive right now, and it is choosing the idle task even if there are other things that like could be run, and so that would be a simple thing we could do. But for the moment, our kind of slightly buggy scheduler is choosing the idle task even when it doesn't need to, but that's fine. And so we're just seeing task 1 fails to create another task. It exited. Task 2. Okay, so this so this is looking pretty good to me, and that's just showing that the scheduler is still working. It's not like the changes that I just made with all of like this super hack stuff did not like absolutely break things. It seems to not have broken things at all. I think the real test we can do to like verify that this is really working is we can look at some of the stack pointers. I just noticed that I can no longer even see how many people are in the stream. It is just showing straight up zeros. So, or showing dashes, so. But I know there's a bunch of people here. Okay, so final thing we'll do today is let's look at the stack pointers. Let's just verify the stack pointers. And so we're gonna quit. I'm gonna restart the debugger, and I'm going to break in create task. And here we are in the very we're here to we're creating the idle task, I think, right now. Okay, and so we are pretty much constructing the idle task, and that gets us here. 84 people in the chat, crazy. What's up? Bye, Ika 9 ow. What I want to show is okay, so at this point we've just stepped through the this function all the way to right here. We've just created, or we've just allocated a task, one of these things with the awful idea. And I wonder if I print, check this out. And so our task is right here. I'm gonna copy this whole thing down to like where we're actually working today. Our task, you can think of it as like our tasks are sort of like 4 blocks here, and like this is the idle task, and so this is task there, and it's at this address, and we can get the pointer of task.stack, which is this thing. It's that big buffer. And so like within the task, there is like this massive buffer. That's our stack. The rest of the data is like an extremely small amount of data. I'm going to kill the palm tree yet again. Why can I not draw a rectangle? An extremely small amount of data up front. This is what our task is looking right now. We have like the tiny, we have like a very small amount of data up front, then like a crap ton of data, the stack thing at the bottom. And what we're doing is basically RSP should point to whatever this number is, 3. I'm still getting used to ghosty with the copy and paste. So -8 hex. So yeah. Did I do that right? Task plus k page size minus size of the pointer. So this is what we should see for RSP on entry, because RSP points like slightly below the top of the stack because of the landing pad. And this is the state of RSP that we should see when we enter the idle task specifically. And so because in our current call frame, we are creating the task for the idle task. And the idle task is at this A1000 thing. So now let me break on scheduler round robin, switch to task. So now we're here in the create tasks, the 3 calls that are in the run function. I'm going to step through those 3. Okay, now we should hit the switch to task and check it out. So we're switching to task at A1000. And so we're switching into the idle task right now. The idle task is the one at A1000. Our switch to task, we're passing in the task at A1000. And therefore, I'm just going to break on scheduler. Well, I won't. I'll do this a bit more slowly. So I'm just going to step through right here. And so here's where we set RSP. And so does that look right? I think that NA. Okay, something. Oh wait, no, I think I had a mistake. So let me just yeah, I think I had a mistake. What I was doing was I was subtracting 8 from the stack, but that was wrong because this thing is the bottom of the stack. So it really needs to be this thing plus page size, which is C1000 minus 8, which is BFF8. And that is what we see here. So sorry if that was like super hard to follow or like very deep, but like basically just the point is I'm quite convinced that like this is RSP basically. So the idea was that, okay, first idea is like the right way to do this is you actually map space in like the general address space for your stacks. The problem is that requires a memory allocator. It's a little bit of a thing to be just like doing. And so I'm sort of deferring like that work. And so what I've done is instead of allocating a stack here, I've allocated a stack completely inside the task here. And I'm pointing the stack right here, right? It's like kind of hard to see. And can I bring this to the front? I'm bringing it right here. And that's where our stack is going to be. The scale is like all super off, but that's like the basic idea here. And we can just see that it's working. We know that it's working because first of all, nothing's crashing. Second of all, it's properly remembering things like the task ID and the current iteration and stuff like this. And so I strongly believe that it's working. And just to close out the stream, I'm just going to run it at full speed, and we'll just bask in seeing this thing rip. So that's the OS. That's our OS right now. That's what it can do. It runs tasks, they yield, they exit, it allocates more tasks, they run, they exit, and it's not crashing yet. Yeah, they yield, they exit. We are we're mapping memory. No, we're mapping virtual address space for the tasks. Actually, wait a second, this is interesting. This is like even a bit interesting. We're actually unmapping pages of the kernel when we do that. So basically, when we get booted, the kernel virtual memory is actually if I can just do another one of our classic physical and virtual memory diagrams, the kernel's like kind of over here. There's some kernel in in the fizz map, because the fizz map has everything. And what we're seeing is that this thing points over here, and this thing points over here. So these alias the physical memory. But in this case, we are remapping this specific frame elsewhere, actually. And so our physical memory allocator is selecting frame for a stack, like other frames of physical memory. And this particular thing, the arrow is super small, is like pointing over here, actually. So the majority of the kernel is pointing at this big block, but what we've done is we've like slightly made some exceptions where certain pages don't point to their original location. They actually point to these frames over here. And we can just see that we can just see that right here. If we look into the vspace.map call, we walk the page table path, we get the page table entry, and then we overwrite it with a different physical frame number. So yeah, like these things like really point to like other parts of physical memory. All right, I lost the chat window. Okay, we went a bit long today, but it was a fire stream, I have to say. I have no idea how many people are in the chat right now, but fire stream. Let me just see what was going on. I missed a lot of stuff, I think. Okay. Okay, Instagram talk. Paging is enabled, but I just haven't really been using it. I just haven't had the need to allocate memory because I've been using static memory allocation for my tasks and everything. Yes, Ableton Move. Can I get the code? Maybe in the future, but it's not public right now, although there is a newsletter sign up if you are interested in following for updates. That's in the GitHub tool, or the Bang GitHub command. New Terry Davis. How'd you learn C++? I watched a lot of videos and I got a job doing C++, and I watched a lot of C++ con talks. Why don't I use Cloud Code? Because I'm trying to understand everything about how this works. How many languages do you know? I know 2 or 3. I know Python and C++. Maybe I don't know if assembly counts. I don't know it super well, but how do you suggest it's good to learn with AI assistants? Yes. Both. Do it on your own. I use AI, yes. I use different models. Doesn't really matter, I think. Looks risky, yup. Looking nice, thank you. This is Hella. Looking cool, thank you, Agman. OMG, wow. What's up, Nishan? What's up, user? Okay, maybe I need to add a C++ command to sort of help people understand that part. That's a frequently asked question. Chat was really popping off today. The work tree. This is lazy Git if you're asking about the Git thing. Just trying to learn. What's the purpose? I'm just trying to understand this stuff. 64-bit? Yes. Yes, sir. Did we reach 100? Did we reach 100? I don't know. I can't even see the number. The YouTube broke, like the stream dashboard like broke for me. So I'm gonna take a big old screenshot of that, pop it into the museum. Custom bootloader. It's Limini bootloader. I think that was answered. 116, crazy. 111. Whoa. What's your inspiration? It's a lot of different things. I mean, I want to understand the systems better. I am just curious to test my own abilities. I want to try using C++ for my operating system. I just want to, just to understand all this stuff better. And the best way to do that is by learning. And I wanted to try this approach with using C++ with third-party libraries and static memory allocation stuff. We are 116. Crazy. Seeing a bit of slowdown in the task menu. You should probably dedicate 5 streams to fixing that. Yeah, so we actually looked into this a couple streams ago. What is actually happening is because I'm using these busy loops to simulate waits, that is triggering the Mac OS, what's it called? Like CPU governor or something like this, and it throttles the CPU. We were looking into this a couple streams ago when I was doing some of my initial testing of the scheduler. So I think we confirmed that it wasn't a bug in the OS code necessarily. Probably one of the best streams I've ever seen. Oh, thank you, No More Night. Appreciate that. For 2 years. Yes, that's since if you're looking at the longest timeline since I started streaming, it's been 2 years, and every step along the way has been a step of progress towards what we're doing right now. And I did various detours. I was working on this MIT OS for about a year, and but I reference it constantly. A lot of what I learned in doing that MIT OS, I'm using right now in my current OS. So. 150? What? Dude, I gotta refresh dude, I'm not even joking. My YouTube dashboard broke. I'm kind of scared to refresh it. I don't even know. Okay, let me screenshot all this. But yeah, I think I'll need to wrap it up pretty much right now. That is exploding. I think I have a theory that the higher the thread number gets, the more my stream numbers are. That's my theory. Yeah. Oh, yo, NSG, what's up? You're joining in the last minutes of the stream. Cursor can make it OS in 10 minutes. That's probably true. When you're building kernel files, do you plan out the structure first or definitely coding in front of the architecture? It's a bit of both. I definitely have a certain design in mind, but it's a quite fluid process. Running a fork bomb test. Not quite. It is spawning threads, but the threads are also dying. So it's more of just a stress test around running tasks, having them yield to each other, and then having the tasks exit. So not a fork bomb in the sense, because there's only ever 4 tasks running at once. It doesn't like oversubscribe the system. I can't even keep up with this. The expression made it into the garden. 36. Any inspiration or something from the Linux kernel? Trying not to invent. I'm trying to do things very differently from the Linux kernel. I'm trying to not use C. I feel like a lot of parts of Linux evolved very organically and without a lot of thought around the design. And I say this as a person that doesn't have a lot of experience with it. That was just my understanding of the history around Linux. I'm trying to take a bit of a different approach and, be a bit more methodical with my design. And using C++ and having unit testing and stuff like this. Man, people spamming? Yo, what's up, Hex85? Shout me out. We worldwide. Who's spamming right now? Okay, spamming is not allowed. Man, I'm gonna need to get a mod. What's up, Afnan? We're using AI agent. Building on the Linux. 100 people. I'm just gonna get Afnan's comment. Yeah. So for the record, Afnan is one of the very, very long-term viewers of the stream. So got that. Yep. Dang, I can't even keep up. If you have threads and processes as a separate concept, you're already different from Linux. Yeah. What's up, Stanley Black? Greens from Kenya. Word. Nice. Thank you for joining. Bro, are you vibe coding? God, this is insane. This is crazy. I'm sorry, Rahul, but you got to earn your place on the board. So it's from India. I don't even know what to do right now. I had some other plans I needed to get to, but this chat is just popping off like crazy right now. I think it's a sign. I think we got to keep chilling a little bit. Dang. All right, I need to text someone saying I'm gonna be late to something. Give me a second. All right, we can chill for a little bit longer since this is so exciting. I'll be late. My stream chat is popping off. 150 viewers. Okay, what do you want to know? What are you doing? So who's spamming? All right, I'm gonna put user in timeout. 5-minute timeout. Whoa. Shout out YouTube. New Israeli chat. Why not Rust though? This is wild. Insta ban. Yeah. More mods or bots. Guventech making their own OS. Guventech, yeah, like join the Discord. Like, I want to hear about it. I think in the gaming industry, they sort of call this a soak test, where you just leave the thing like running for a long time. NSG, what is the scheduler algorithm? Yo, this is hype. This is hype. Yeah, it's cool to see people getting excited about the stream. So for the record, NSG, Ismail are also two of the very, very long-term supporters and members of the community. So they get on the board too. Yeah, everyone should go check out NSG's OS, by the way. I mean, he's working on a secretive new one, but yeah, I'm just gonna, we gotta make sure we shout out the people. NSG is probably one of the most experienced OS devs I know, so check out Polaris. This is a bit wild. It's a bit hard to keep up with all this stuff, to be honest. What's the scheduler algorithm currently? It's a round robin, and it looks like this. So to do the policy, to do the scheduler policies, you make a struct and you implement choose next task, and you get a linked list of tasks, and you get a pointer to the current task if there is one. And then if there is a current task, or rather, if there's no current task pointer, we set the start of the search to the begin iterator of the tasks container. Otherwise, we we get the current task and then go to the next one as the starting point for the search. And we just it needs this helper that just handles the wraparound case if we were at the end of the loop. And then we just search through all of the tasks for a runnable task. So nothing fancy, no run lists, nothing fancy like that just yet. Just very, very simple, very, very simple stuff. Sorry, man, this is crazy. I would say no. I don't think I'm vibe coding. I use AI, but I'm not vibe coding. ULE, not sure what that is. Least. All right, peace out, VA80. Gotta. So what's happening here right now? We are just vibing. The vibe just really popped off. I sort of finished the stream. Like we did like 3 hours of programming, and then now I'm sort of just like kind of letting the OS run and stuff, and we're just vibing it out because like 100 people joined the stream. So I do not have a setup yet. I have my setup. My tools come in with a couple of just the tools I'm using. James is real. James is real. Software engineers are like plumbers. Do you agree with that statement? You know, I think I've heard that in like the Linux world. Let me think about that. Are like plumbers. How are they like plumbers? I guess people work on plumbing sometimes. Like certain parts of like systems, like back-end systems are sometimes called plumbing. But I'm not sure. I guess I'm not really sure. I think I don't really know what plumbers do enough to really say. Plumbers connect things together. They fix water leaks. I think not all engineers are just connecting things together. Yeah, I mean, there's a certain amount of connecting systems, managing flow. I'm not sure if everything is like that, though. You look peaceful today, bro. Thank you. Not gonna lie, I think I cracked the code for streaming. You just need to have something that is just dumping a lot of output to your terminal at all times. And that is gonna mean that's gonna instantly get you 100 viewers. That is instantly gonna get you 100 viewers. You just gotta just dump a bunch of stuff into your terminal all at once. What's up, everyone? Hacker man, for sure. Yep, Lemony bootloader. Constant time scheduler sets priority based off of how interactive a process is. Which wait on any event get a lower priority. Elementary hacker kind of stream. Text. Yeah, I'm using Tmux. All right, I just had an idea. Since we're just going over time, I get so many requests for my setup, and so let's just do that right now. I've been like procrastinating on making a video on that for so long. I'm just gonna do a video. I'm just gonna explain it all right now, and then maybe I'll upload this to YouTube as a separate video. So people ask me all the time, what's my dev setup? And so let's just talk about that. Well, first of all, what does the tools command say? Because I'll just start from that. If it ever responds. I use a bunch of tools. I use text editor, right? So let's talk about the dev setup that I use for doing my OS development. And so VS Code. I'm using VS Code as my primary text editor. I like it. I like the GUI. I like that I can navigate very quickly around it. I'm not using it right now, but the integrated debugger is quite nice. I like that there's this very nice set of extensions you can get for it. I like that things generally work pretty out of the box with it. So I'm using VS Code as my primary text editor. Whoa, did I just see another donation in the chat? I really failed at getting a screenshot of that. Okay. Thank you. Thank you, James. So, VS Code. Next up, let's talk about my terminal setup. I recently switched to Ghosty terminal. And here's my config. I was using iTerm2 for a long time. And actually, this is actually maybe a good example. This is the sort of situation where Ghosty actually excels, where it's a lot of output and the terminal needs to re-render itself very, very quickly. And so iTerm2 maybe would have struggled with this. So I'm using Ghosty. I mostly use Ghosty because I like having a very simple config in a text file. iTerm2 had a lot of GUI config that I just didn't understand. I wasn't using. What's that? Tmux. I'm using Tmux for my dev setup. So I have Tmux, and I can make new windows and split them and stuff like this. I can exchange them. So I'm using Tmux, and I really like using Tmux. I often have this setup, you'll see, where I have half the right side be a lazy Git, and then I have various working kind of skinnier panes on the right for like an IPython for some math, or my debugger, or the build. And that is a good segue into lazy Git. I'm using lazy Git as my primary Git client because it is the most powerful one I have ever seen, and you can do things really quickly with lazy Git. And it's just super fast. You can rebase, you can split commits, you can merge commits, you can invert things, you can do all sorts of stuff. It has good integration. I can click a line here and then open it up in the text editor. That's pretty nice. There's like some highlighting and stuff. Lazy Git is a really excellent Git client. Okay, now a bit about my OS dev tools. I'm using the LLVM toolchain, meaning Clang, LLDB, LLD. I'm fully, like ClangD, I'm fully bought into everything being LLVM. And so the way it works is I have a toolchain installed. Currently my OS is targeting LLVM 21. I have a toolchain, and I set these environment variables so my build system uses this LLVM toolchain as my toolchain. So I'm fully bought into LLVM, and what's nice about this is I'm using ClangD for my code navigation and finding references, jumping around, stuff like this. All sorts of good stuff you get with that. ClangD is the source of those things. VS Code has a great ClangD extension which I'm using, and then I have a .clangd file which points at my build directory. And I have a build directory that's generated by my build system, and so I have subdirectories for the target compile, which cross compiles to the target architecture, which is x86. Then I have the host build, which is for binaries I build to run on my host Mac system, which is an ARM system. And in that case, it's for my my unit tests, which I can build and run. So I have unit tests for my kernel, and so that doesn't run on the target system, that runs on my host. And so I have the host and the target, and the compile commands changes based off of whichever I'm working in right now. And so I just built the host, and so if I go to my tests, and then I IntelliSense to go to this thing. Let me just actually. That's actually a little bit unexpected, but I won't go into the details. But anyway, I have my clang D and compile commands JSON set up for that. I'm using QEMU for my emulation and like actually running the kernel in a simulated environment. So that is what we're using. I'll kill the kernel just now. When I run things, it runs in QEMU, and that's also how I'm able to debug things. It also, when I run it in debug mode, it runs QEMU with the debug server enabled, and then I can attach with LLDB and then break and step through my kernel. So that's that. I'm using CMake for my build system, and I'm really excited about how clean the build system looks. I'm able to separate the host binaries from the target binaries. I'm able to have very clean handling of third-party dependencies this way, and I'm overall just really happy with the CMake build system. I'm trying to think if there's any other tools I'm using, but these are the main ones. I'm using Vim in VS Code, the VS Code Vim kind of stuff. I recently discovered this thing called flash.nvim, which lets you jump like anywhere super quickly. I can jump like that, so that's really cool. I can just jump around. Yeah, so I'm using Vim bindings in VS Code, and I think that is pretty much an overview of all of the tools that I'm using. So, oh, Limini bootloader, of course, Limini bootloader. Yes, that's the bootloader I'm using, and it makes it really easy. My K-main is just really nice. I have that. I have my Limini requests for getting the command line, the physical base, the virtual base, stuff like that. So Limini is, yeah, a nice tool. So that is pretty much it for a tour of the tools I'm using every week on stream. Oh yeah, Fish Shell. I'm using Fish Shell, which just, I don't know. You know, you get these like tab completions. I'm using a make file to help me just make it a bit easier to trigger my build targets with just like these nice simple commands. So yep. All right. So yeah, that is a tour of my main tools for OS development. And thanks for watching. Yeah. And I don't know. That's pretty much it. I think I gotta get going, guys. I hate to leave this chat, which is just popping off so crazy, but let me just this is, yeah. Thank you all for joining. This is like one of the first, Josh, you don't even make an OS for me. You don't, it's really a new experience for me to have so many people in the stream. Oh no, expired. And I'm still navigating about how to handle this. That's in the top chat. There's also the live chat, which is even faster paced, I think. All right, I'm just gonna finish the stream by saying thank you very much for joining. Please subscribe to me on YouTube if you are enjoying this content. Feel free to join the Discord. And follow me on Instagram. Follow me on Instagram, y'all. All right. That's going to be it. I hope you have an amazing week, and I would love to see you back next week where we keep it rolling and keep working on this OS and the scheduler and all that kind of stuff. So with that, thanks a lot. Have a great week. I'll catch you later. Peace.